All right, so let's go through those questions with this one. So we got here, we made everybody happy, we got to the central atom, he already had 8, so we were done. So we didn't have to move electrons to make the phosphorus happy. But now we need to say, well, can the phosphorus expand? So we look here, where's phosphorus? He's in row 3. So if he's in row 3, that means he has the option of expanding. So phosphorus can expand. So now the next question would be, is he going to expand? So what do? We have to do the formal charge on him and anybody attached to him that has electrons. So we don't do the H because he's 2 atoms away. We do these oxygens, which are all the same because they have the O's with the H's, and this one. So the way we notate this is the O's with the H and the O alone. Okay? So let's look. How many does phosphorus have? Phosphorus has 5 valence, oxygen has 6. Okay? So phosphorus has 5, oxygens have 6 valence electrons. All right? So now let's count it up. Phosphorus, does he have any electrons just on him? Nope. How many bonds does he have? 1, 2, 3, 4. So he's going to be a +1, which means, oh, he would like a double bond. So let's see if anybody will give him one. So let's look at the oxygens with the hydrogen. Just do one, and it's going to be the same. He's got 6 valence. How many's on him? 1, 2, 3, 4. How many bonds? 2. So that gives me a 0. So these guys are like, I'm good, I'm chilling, don't mess with me. Let's do this oxygen. He's got 6 valence, he's got 1, 2, 3, 4, 5, 6 just on him, and 1 bond. That means he's a -1. So what that tells me is he wants a double bond, he's cool with giving it to him. So he's gonna move these electrons here to make the double bond. So these electrons move here to make the double bond. So I can just erase them and make my double bond. He still has 8. 1, 2, 3, 4. Here, let me move my little cursor. 1, 2, 3, 4, 5, 6, 7, 8. Now phosphorus has more. He's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might say, well, does he want even more? We could do the formal charge. 5 minus 1, 2, 3, 4, 5. He's at a 0. He's happy. So we're completely done with him. That's what he wants to look like. No other choices. Done. All right, let's do the next one. Sulfur. This is where we were. We had 2 extra electrons, so we put it on there so that he was happy with 8. So he's complete. He's happy with 8. But could he be happier? Let's check. Where's sulfur? Right next to my phosphorus in group 3, or row 3, sorry, period 3. So he can expand. So sulfur can expand. So will he? Just because they can do it doesn't mean they will. Okay? So let's do the math. Let's say we need to do sulfur, and all the oxygens are the same. So I could do sulfur and the oxygens. All right, let's look. Sulfur and oxygen both have 6 valence. They both have 6. How many electrons are on the sulfur? 2. How many bonds? 1, 2, 3. So he's a +1. Okay? Oxygen, how many does he have? 1, 2, 3, 4, 5, 6. And how many bonds? 1. He's a -1. So each one of these is a -1. The sulfur is a +1. So what that tells me is he wants a double bond. He will give it to him, he'll give it to him, and he'll give it to him. They don't all get to do it because sulfur is only a +1. If he was a +2, that means he would want 2 double bonds. But he's a +1, which means he only wants 1. So that means you have 3 choices, but they're all the same. We have a name for that, and I'm going to talk about what that is in the next little section that we're on. It's called resonance. It's not like another step or anything, okay? It just means when I have equal choices, I can pick either one of them, and they're all the same structure pretty much. So it doesn't matter. Pick one of the oxygens, make a double bond. I'm just going to pick him. So he's going to move the electrons here to make the double bond. So I can just go in, erase those electrons, and make the double bond. So now sulfur is going to be at 6 valence minus 1, 2, 3, 4, 5, 6. So he's completely happy. He doesn't want to do it anymore. yes, these guys are still going to be at a -1, but since he's at a 0, that's it. We're done. We can't do any more expansion. So he can't expand more because he's happy with what he's at. All right, let's do the next one. So I put these electrons on the phosphorus to make them happy, but can they be happier? Let's look. Where are we at? Here's phosphorus, row 3, so he can expand. So phosphorus can expand. So let's see if he's going to expand. Now, I need to do it on the one that's going to expand, but then do I do it on the hydrogens? No, they don't have any electrons. So I can't do it on the hydrogens because you have to have electrons to do it. But even if you forgot, you could try to do it. It's not, and you'll find that hydrogen has 1 valence, 1 bond, he's zeros. Let's do the phosphorus just for an example. Phosphorus has 5 valence electrons. He has 2 on him, and he has 3 bonds. So he's also at a 0. So even though he can expand, this is an example of where he won't, and he is completely happy and done. He says, I don't want you to mess with me, because the only thing I could do is move these here to make a double bond. But they're both zeros, and I can't go from hydrogen because there's no electrons. So you could actually look at this and no, you don't need to do the formal charge. But if you weren't sure, you could do the formal charge, and the formal charge would tell you 0, 0, 0, 0, 0, 0. Everybody's happy, don't mess with us. All right, so that is formal charge. You have done it all. So the last thing we're going to talk about when it comes to our Lewis structures is resonance, which I mentioned here. Okay?